I'm Andrew Carnegie. I'm the Managing Director of Sentry, and you have to bear with me a little bit because this is a little bit ad hoc. But what I'd like to do is to just very quickly run through a thought process or a thought project. So I'm not trying to sell a product here. I just want to have a quick review of an existing situation and look at some of the things around that very quickly. And when I get the slides to work, bear with me, sorry. There we go. So, very quick overview of the net zero policy. I know everybody here is an expert on it. I'm not, but I'd like to just revisit it very quickly in terms of its timeline. I'd like to very quickly look at ventilation within that policy, specifically HTMO3, and then very briefly look at how innovation might help the ship arrive at the end of the policy. So if we have a very quick look at Simon Stevens when he came up with the initial 2020 green rate NHS, and the thing that everybody has to be aware of course, is that the pandemic started a week later. And when you look at the policy document they came through to delivering a net zero NHS in October, this is a significant achievement. It's a very good document. It's a very good macro strategy document. And that comes up with some key points, 8 key figures that it's trying to aim within that strategy. And the one that I'm particularly interested in, because we're looking at ventilation, is actually our people, our hospitals. We're looking at the intrinsic estate structure. And if we look at how the idea of that policy with the document, I think most of you have probably read it at least several times. We're looking to try, both as suppliers, as estates managers, as project managers, to bring together reductions, evolution of new approaches. And also towards the end of that approach, when you're trying to look at the very fine detail, also innovation. Now, we're looking at big concepts within small spaces. And very much what we want to do is in terms of ventilation, principally look at the tier 1 emission risk, or the emissions that occur within tier 1. And if we look at that, then IHEAM did another document, which again is a very, very high quality document, which looks at the engineering approach to how you might look at ventilation and other things within that to reach net zero 80% in 2032. And quick, somebody will probably say that's not quite right, please don't shoot the messenger, but approximately 4% of UK emissions, total emissions are NHS in total, and about 10% of that is power. IHEAM say that 15 to 35% of that is ventilation, and I took a midpoint of 25%. Nobody actually knows exactly what it is. And at a £40 per tonne, it totals around about 16.2 million at 2020's figures, and it goes through to 48 million at 2050. Now, that's per annum, and that actually equates to 10% of the target that the NHS is trying to achieve. So ventilation itself could be deemed, therefore, to be quite an important aspect of what we're trying to achieve as a group of people in trying to reach these goals as we move forward. And we then, therefore, come to thought within policy and how the regulatory environment looks at that policy. Now, HTMO3 has just been released. It was delayed, released in July last year. And HTMO3 provides the regulatory environment for all healthcare ventilation. I think most of the people here, again, probably know that far better than I do. And one of the things that changed in HTMO3 in July 2021 was there was a reduction in OR air change rates. And that reduction was very small. It was from 25 air changes to 22 for some of the OR areas. I'm very pleased that Camphor are nodding on the left-hand side. I've got that one right. And I worked out that this approximated to a saving of around about 650,000 per annum, just in that small change. Now, OR is a very, very well engineered example, and it's probably the one in terms of these thought processes that you would address towards the end, other than we're trying to reduce nitrous oxide and other emissions, and so there's a move towards no gas anaesthesia. And so therefore some of the air change rates in these areas may not be the same in the future as they are today. If we look at HTMO3, for most areas outside of OR, you will always have sealing supply and you will always have sealing extract within the regulations. And what this means is that the main vector flow of that air current that has occurred, quite naturally, like a river, travels from the point of input to the point of extract. So your fastest vector flow is across the sealing. And it's well known and is recognised in the new HTM that this means that the air change rates that the health service thinks it's getting in any particular area is not necessarily what they are actually getting. And the reason is that the airflow is occurring for 12 air changes across the ceiling, so most of it's not being used. And then at the lower levels, you may find that the air change rate for 12 at the ceiling might only be 2 or 3 at patient level. And in fact, in some areas, depending on how it's designed, can actually be stagnant. And we've got clients within the UK where we've gone in and done 1 micron smoke dispersal testing, which is an on-site way of looking at air currents, where you can actually see that the air current at this level isn't operating the way that people expect it does. We've also got a huge existing estate. I think my memory is about 90%, where the existing estate is known for a lot of the ventilation to not be fit for purpose. And the reason is not because of the design of that, not because of the regulations, but over the years people have moved walls, they've changed things, some things aren't maintained sometimes, but the end result is that we've got a ventilation situation that isn't quite the way people think it is. And if we then go through and look at HTMO3, and I leave that up for just people to have a quick review of, when we look at HTMO3, we have a conflicting situation because on one side recirculation is not to be accepted, and on the other side recirculation is accepted, and it just depends on what environment is involved. But the key premise of this is dilution, and dilution within an OR area, particularly laminar flow theatres, is accepted with recirculation at high flow rates as being a very good way to achieve dilution. But if you then take that same premise and apply it to a ward area, you'd be told no, we can't accept that. And so we've got this interesting situation with the regulations, which is a historic one, where some things are accepted and some things aren't, and it's not necessarily clear. As I just said here, you can see that the design philosophy is conventionally ventilation suite is based to dilute contaminants, and you have a situation where engineers do a very, very good job, both from a regulatory point of view. IHIM do a very good job from a regulatory point of view. The guys that have written HTMO3 have done a very good job from a regulatory point of view. But by nature, and it's something that you don't want to change, engineers have to be risk averse. We have a regulatory environment where you want to proceed and evolve things, but you don't necessarily want to innovate in the way that's going to change things from those regulations. And at the same time, we have the same situation with IPC. IPC, for exactly the same situation, are also potentially risk adverse because you want to make sure that anything that's applied in terms of patient environment is safe for patients, is safe for staff. And so you've got this natural situation where things are held back from an innovation point of view. But bearing in mind the macro strategy is to look for innovation. So as we come through then and we look at air purification, which we can argue is recirculation with filtration in laminar flow theatres, which we already know in the regulations is accepted. There's a building evidence, and there's quite a large amount of evidence, that air purification works, that it's able to remove contaminants from the air, that the filtration standards, because it's passive, are well known, and in a modular basis actually may be able to offer the end client something where they can actually gain a similar environment that they expect to get, possibly a better one, at lower cost and lower emissions. But the problem is the regulations, of course, are confused a little bit, or they're not necessarily supportive of taking particular approaches. And so you have this standoff. And at the same time, we've got things like SIBC, which for airborne disease and patient safety said that the thing that you want to do in reducing emissions and sustainability for ventilation is look at recirculation and heat recovery. But you don't want to do that for patient safety points unless you ventilate, unless you filter. And if you're going to filter with that type of recirculatory environment, then you need bigger plants, bigger costs, more energy. So it's a difficult situation. And so this thought experiment that we're proposing is to say, look, how can we bring the two things together? How can we provide an environment that the regulatory side of things, the HTMO3 side of things, the AEVs can look up and say, this is something we know works, we can sign it off. How can we bring together something that the IPC colleagues can look at and say, this is the data that we have, this is what we need to be able to make these decisions, and bring the two together so that the ventilation safety groups, which the HTM has suggested, which I think is a brilliant idea, can actually say, this is something that we can sign off and works. We know this works. We can therefore move towards net zero on this progressive basis because we have everything we need. And so if we then look at, if anybody wants to know about the ship, by the way, it was my boat. I can tell you a bit about disaster planning. So if we come back to our existing ventilation strategy, you have sealing input, sealing extract. Now we also know that if you take high level input and low level extract, that actually the ventilation engineers will straight away say that your vector flow is across the room from high level diagonally across, therefore that will give you more of the air change rates you expect to get compared to the conventional way of doing it outside of OR, because ORs are already do this. And so what we're looking at therefore is that can we put together a simple product that will go into as a duct system that the engineers can sign off and say this is HTMO3. At the same time, and I'm going to give you, it's a prototype, it doesn't actually exist, so I'm not selling anything here. If you look there, if you actually had then high level input and low level extract, then you can see that you're able to produce a central clean zone, which is very similar to what you're trying to do with laminar flow theatres, but could possibly be done at a much lower cost. So this is the thought experiment, the prototype that we put together. You're welcome to come over and talk about it if you want to. The idea is that within this, you can sign it off as a duct. So you can sign it off as an HTMO3 low extract duct. It's 250 mil wide. It does nothing else. There's no fans, no filters, anything else. It just gives you low level extract. It goes into any existing room. At the same time, if you then later, because you have an HTMO3 compliant area, want to do something passive within that, and the emphasis is on passive, because if it's passive, obviously you're not doing anything. You're not trying to do something like, you know, the laser death killer things that we've seen marketed throughout the pandemic. What you're trying to do is remove something that's known that its removal is actually beneficial to the environment. Filtration does that normally. And so you can then add in, the engineer can add in a filter if he wants to. He can add in a module then to give recirculation after it complies. At the same time, another module that's able to go in will allow the engineer and also the IPC guys to measure things like VO2, CO2, flow rates, temperature, humidity. We're looking at radiation and stuff, that sort of bits and pieces for some areas. So that you can collect and actually collate the data that's produced for that ventilation system. And at the same time, you want to be able to relate that to what IPC would like to see, which is counts, CFU counts on an agar plate. And so by being able to put into this, into the incoming airflow, a plate against the timed airflow, so you know exactly what you collected over what time, you have your data, you have historic data, you're able to see exactly what the situation is within a compliant area, and at the same time you're able to then look at the microbiological data that you need for that area. What it means is that you can run, let's say we've got an ITU that's running at 12 airflow changes an hour, and those are proper air changes because they're actually diagonally across the room. So the AEs actually know that they've got a better situation than they would normally have. We're then able to say, look, okay, fine, if you want to, because you can just leave it at that, if you want to then put in a recirculation system, if you want to put in something to collect the data, then we're able to look at this, and you're able to say, then make an informed decision and say, okay, we'll reduce this by 1 air change an hour, as an example. And so we reduce it from 12 to 11, and we compensate with air purification. What that means is that we've then in a situation where the engineers are happy, they've got something that complies, IPC are getting the data they require to be able to sign it off, and then they can make informed decisions within any area that the systems here, or this type of system might be, where they can then say, well, okay, we can gradually reduce this. Now, anecdotally, and I think I'm almost out of time, we know we've had 22 years of doing this type of thing within the NHS clinical environment. And we've got clients where we know that their nosocomial risk has been reduced to near zero. Now that's not just us. When we do anything with ventilation, any ventilation change is not a magic bullet, it's not a silver bullet. But when you add good ventilatory control to robust IPC approaches, then you reduce infection risk. And so by extrapolating that out, not only then do you save money straight away on the sustainability side, but you also reduce and mitigate the risk to the patient environment. So it's potentially a win-win situation. But the thought experiment is how do we bring these two groups of people together and help them get what they need to supply the end result, which is hitting net zero at 2032, 80%, from a ventilation point of view. I'm very happy to take any questions. I think I'm still on time, and Clive hasn't thrown me out just yet. So the
premise is to introduce an air purifier within the ductwork, and then consequently be able to turn the system extract volumes down.
yes, if you want to, or if you decide to do that. See, as a manufacturer, as a supplier, what's happened over the last 20 years is we've said, here's our product, it beats, it sweeps, it cleans, would you like to buy it? This is slightly different. What we're trying to say is look, here's the facility, these are what you can do with it, what would you like to do with it? And it's a little bit more like the smartphone type thought process, you know, that we're providing the framework, the base framework at a low cost that would allow you to then make those decisions. But actually the imposition of those decisions and the responsibility will always come down to the clinical team, the engineers that are involved, and we're just there to help facilitate that.
Have you done any work to identify what the difference is, say for example putting your air purifier, and that's going to introduce a static pressure drop on the system, isn't it? So that will consume energy.
You'd imagine it would do, and you're absolutely correct if it's only in the ductwork. But the thought experiment we came up with is actually the recirculation system is parallel, and so there's no back pressure of the plant, and also we are supporting recirculation alongside existing extract. And the most important thing is the extract's there. So you've actually got a parallel system. So you're absolutely correct. If you, and that's one of the issues you have with trying to put high density filtration into existing ventilation systems, is you either then end up reducing the flow to the extract or you back pressure the plant. In this situation, that doesn't happen. We've got experience of doing this with our existing systems, and the way we've done that is that there's actually, when you bolt it onto an existing HVAC, because there's a space to the filter, it still pulls round, but if you try to over-pressurise it, it'll flow around the filter. So it's a very simple but very effective way of doing things. Does that answer the question? Anybody else at all? So thank you very much for listening to me. It's been a real pleasure. Thank you.